Let's look at some examples in which we need to solve using substitution of quadratic equations. So let's look at the equation x to the fourth minus a 3x squared minus 4 is equal to 0. This one, we could factor it the way it's written. It's a little bit more difficult. Let's just let u equal an x squared. Because again, remember, whatever here is in the middle term, that's what we're going to let u equal. So we put a u here, and this is u squared, because if you think about u squared and then we square it, that would give me x to the fourth. And then I just bring down my coefficients and everything, and I can factor this, and I would get u minus 4 times a u plus 1 is equal to 0. So u minus 4 is equal to 0, and u plus 1 is equal to 0. So u is equal to 4, and u is equal to a negative 1. Then I'm going to come back over and say 4 is equal to my x squared, and that my negative 1 is equal to my x squared. Because remember, once I get here, I have to come back over and set it equal to whatever I let u equal. And so then, since this is x squared, I'm going to take the square root of both sides, remembering my positive and negative. So I get plus or minus the square root of 4, which is going to be positive negative 2. So x is equal to positive negative 2. And then I'm going to do the same thing over here. And so I get square root of negative 1, which becomes positive negative I is equal to x. So my solutions for this one are positive negative 2 and a positive negative I. I have a total of 4 solutions because I have it raised to the 4th power. Let's look at another example of this. Let's look at if we have x to the 2/3 minus a 3x to the 1/3 minus 4 is equal to 0. So I'm going to let u equal a 1/3. I'm sorry, x to the 1/3. So then I would have a u squared minus 3u minus 4 is equal to 0, which we just saw. That's going to be u minus 4 times a u plus 1 is equal to 0. So u is going to equal 4, and u is going to equal negative 1. But again, I need to let 4 equal x to the 1/3, and a negative 1 equal x to the 1/3. Since I have a rational exponent, I'm going to raise both sides to that denominator. And so when I do so, 4 to the 3rd power is going to be 64. And then I raise both sides to the 3rd power over here, and I get that x is equal to a negative 1. So my solutions are 64 and a negative 1. let's look at if we have 1 minus 3 over x quantity squared minus 7 times 1 minus 3 over x plus 10 is equal to 0. Now in this case, I'm going to let u equal my 1 minus 3 over x. This way I get u squared minus 7u plus 10 is equal to 0. So then I factor, and I get u minus 5 times a u minus 2 is equal to 0. So I get u is equal to 5 and u is equal to 2. So I'm going to have 5 is equal to a 1 minus 3 over x and so I'm going to subtract a 1 from both sides. So I'll get 4 is equal to a negative 3 over x. To get rid of this x, I'm going to multiply both sides by an x, because I got to get rid of the denominator. So I get 4x is equal to a negative 3. Then I can divide by 4, and I get x is equal to a negative 3/4. I'll do the same thing with my 2 is equal to 1 minus 3 over x. Subtract my 1, and so I'll get 1 is equal to a negative 3 over x. So that will give me an x is equal to a negative 3. So my solutions are a negative 3/4 and a negative 3. So in these cases, we are letting u be a value, usually our middle variable or middle term that's being multiplied by something, so that we can substitute and then factor so that we can solve a little bit easier.